Hello and welcome to Topper Machine. I'm Josh Topper, and today's job is a threading job for the Lion lathe. Now this job is one that I've done in the past on video, but with many newcomers to the channel and the growth we've seen, I decided we'll film it again because it seems to be nobody really wants to go back and watch the older stuff, even though there's some really great content there. So here is the pallet of material for this job. This is all 2-inch cold rolled 1018 bar stock, all cut to length for what is needed. And what we're going to do is thread 12 inches of one end of it to a 4.5 thread per inch. Now, as is normal with any of my videos, I'm going to get a lot of comments of, I don't know what I'm doing it wrong, that's not how you do that, blah, 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 blah. Too bad, this is how I'm doing this job, and this is what the customer wants, and they're happy with it when they get the finished product. So, with that, let's get on to the job. All right, so the very first thing I'm going to do here is I got it chucked up real short. That's because the chuck will hold it as close to concentric as possible. 3-jaw chuck is actually very good. And we're just going to center drill it so we can get it in the center on the other end and then slide it out past what I need so I have room, because we're going to use the pull-out method for threading this shaft. All right, I'm going to use a dab of anchor lube on this for the center drill. Instead of using my flood coolant and throwing that everywhere, we're going to run 250 RPM for the center drill, and we'll just get this drilled. All right, so we need to do 12 inches of thread. I'm actually going to pull this out about 15. I want a little bit past, so I have my run out for stopping the chuck and everything when I come out of the thread. Like I said, we're going to be using the pull-out method, so this will work really well. Now, what I always like to do with the thread is I like to start a chamfer on the end of the shaft with the threading tool. It just seems to match a little better and work really well. And there, that looks good. I'll come down and touch off here and zero everything out. Now, this is 250 RPM, and I'm almost thinking this is going to be a little bit on the fast side. With a 4.5 pitch, that's feeding pretty rapidly. So let's engage the feed and just see what it looks like. Yeah, I think I can work with that. All right, so I'm going to start down here at the 12-inch spot. I'm just going to make a mark with my insert so I know where I'm pulling out, and then we'll start threading. All right, I like to do my first few threads just go straight in. On these deep threads, it just works a lot better. There we go. Okay, that's going a little bit quicker than I like it, so I slowed down to 180. We're just going to engage and make sure everything lines up, and it still looks great. So we'll go back and make next pass. All right, we're peeling off some really nice coil springs, but I think we're getting to that point where we need to start coming in with the compound. But overall, she's looking really good. All right, so the last pass I had gone into 210 thousandths deep on the digital readout. I backed it off to 200 and then I went in 20 with the compound. So let's cut this next one and see how it looks. Yeah, beautiful. That cleaned it up nicely. I'm got the compound at 29.5, and that's looking really, really good. So we'll just keep going with that. Okay, now I've got my thread measuring triangles out here, and we're gonna give these a go. I already calculated out my pitch diameter, so let's just see how much more we gotta go. And I think we got a ways to go. Actually, I know we'd have a ways to go. 2.114. And by my calculations, we need to go to 2.0604 or 2.0461. So we got a little ways to go. All right, I was getting very inconsistent cuts there, and as I see right now, we broke our insert. Not a big deal, I'll just swap that out. All right, I'm gonna start a little bit shallower on this pass just to kind of make sure we don't have an issue. And yeah, we're just touching, I'm just turning it in. All right. All right, I'm gonna take one more light pass here and then measure and see what we got. But I think we're getting close. Well, there's a fun one. The chip got underneath the clamp and is stuck right there. Well, let's see roughly where we are. Up there. 1067, so we don't have much to go. I'm just going to take another nice light pass and we'll see what we got right after I get my antenna out of here. I'm going to try the nut, just see if it fits. All right, so this is a 2-inch 4.5 nut that my customer supplied me to check all their threads with when we're doing these. And like I said, we are over thread diameter, the pitch diameter. We're actually a 1 thou bigger than maximum, and look at that. It fits just beautiful. Other than it is a little loose for my liking. But it's within tolerance, within spec, so we'll just spin this all the way down, make sure it's still good all the way. But I think we're gonna be fine. I'm picking up a little chip there. I'll grab the air hose and blow this off. So it's getting a little tighter there. I think I'm just going to run a spring pass just as it was, but no deeper, just a spring pass, and clean it up a little bit, and that'll get me under the maximum pitch diameter. All right, that last little spring pass did pretty good. It took off a little more right where I figured it would want to. We did get a little bit of chatter through here, but God, running my fingernail over it, you barely feel it. So I don't think this will be a problem. I'm gonna run the file over it and then this is done. Well, that came out really well, and I apologize if this is just a shorter video than normal, but it's a very basic, simple job. Thread a shaft 12 inches long using the pull-out method. Pull out at the end instead of cutting a relief, and it went really well. And I've said it before in the past about these nuts that the bigger they are, the less the tolerance seems to be correct. They're always not within tolerance. Some of them are tighter, some of them are looser. They're kind of all over the place, so you really need a nut or a couple of nuts out of a batch to test against the customer's parts. That seems to be the best. Like you saw, I was 1 thou over my pitch diameter with measuring on the thread triangles, but the nut went right on and it was a little bit loose. So, and that was calculated out for a 1A fit. So it was loose for a 1A. That's pretty loose. So with that, well, a 1A is pretty tight fit. So it was pretty loose for a 1A fit, but it'll work for this. The customer will be happy with this. They want them to spin on there nicely, and that's what they've got. So with that, I'm gonna finish up get this one out of there and get on the rest of them and try to get this job out the door here tomorrow. I've got 16, 18 of these to do. So a nice little pile and finally a decent payday coming. So with that, until next time, get out in your shop and get it done right the first time.